Hello students, today we'll see the concept of trees in data structure. Okay, so far we have seen different data structures that were linear. Okay, so those were arrays, linked lists, stacks, and queues which stored data in a linear format, sequential format. Okay, now let's see trees, where tree is a non-linear type of data structure. Non-linear in the sense the data is stored in a hierarchical pattern. Okay, it has a relationship between its elements. Okay, for example, records or family tree, the contents of a table, right? These are stored in a hierarchical pattern which represents the child and parent relationship. So, tree is an abstract model of hierarchical structure that consists of nodes, okay? And these nodes represent the parent and child relationship, okay? It is a sequence of nodes. Over here, you can see the tree is starting from node A, okay? So this node A is considered as a node, right? It is the starting point of a tree. So every node has a root node, okay, and it is considered as a parent node also, okay. So now from A we get three nodes, that is B, C, and D. So these nodes are considered as a child node of parent node A. Let's consider the example given here, okay. So over here, node A is considered as a parent child. As it is a starting point of a tree, it is also considered as a root node. Okay. So B and C are child node of A. So this B and C are siblings of each other. Okay. Because they belong to same parent node, that is A. Now B is again a parent node as it has two children again, D node and E node. So D node is considered as its left child and E node is considered it as a right child. Okay. So again, D and E are siblings. Over here, siblings to each other because their parent is same. Okay, that is B node. Okay. Now over here you can see a node, parent and child relationship over here, which itself becomes a subtree, subtree of existing tree. Okay, so the edges that connect two nodes is called path, or even you can call it as a edge. Okay, so the root node is at level 0 of a tree. Okay, so after that, the nodes that are connected to root node are at level 1 and so on. Okay, they keep on moving as the tree grows further. Okay, so over here you can see the concept. The siblings, okay, siblings are those nodes which belongs to same parent. Okay, then the last node, the node which don't have any child nodes further, are called as leaf nodes. Okay, that are the external nodes of the tree, the end part of the tree. Okay, whereas the nodes that have children, child node, are called parent nodes or internal nodes of a tree. Okay, so let's revise some terminologies that are frequently used in trees. Okay, we have seen root. Root is the first node of a tree, which is at the top of the tree, is called root node. Okay, the parent node is a node that has one or two child nodes. Okay. Child node is the one who has parent. Okay. Then sibling are the nodes which are child nodes that belongs to same parent is called sibling. Okay. Then leaf node. Leaf node is the last node, outer node of the tree which has no children. Okay. Subtree is the tree that it represents within a tree. Okay. And the level, the root represents zero and it moves on further as the tree grows. Okay. Then keys. What are keys? Keys are used when we are searching a node in the tree. The value that the node holds is key. So, so far in the example we have seen A, B, C. These are the values of the node, right? So those are the keys of a tree. Okay. Then degree. Degree of a node is the node that has children. Okay. So over here we can see A node has two child nodes. So the degree of A node is 2, right? Over here we can see that E node has only one child node. So the degree of E node is 1. Whereas H, I, J, these nodes have no child node. These has 0 child nodes. So the degree is 0. Okay. So over here, the degree of the tree is the maximum degree the node has. The maximum degree is 2, right? So the degree of tree is 2 over here. Over here in this example, we can say the degree of A is 3 as it has 3 child nodes. Okay. The degree of B is 2, degree of C is 1 and degree of D is 0. So the degree of tree is 3. The maximum degree in the tree is 3. So the degree of tree is 3. Okay. So let's see the path. Path is the edge that connects two nodes is the path. Okay. Then height of a node and height of a tree. Height of a node is calculated from its leaf node. Okay. So height of a H node is 0, whereas the height of D node is 1. It is one node away from leaf node. Okay. The height node of B is 2. The height node of root node, that is A, is 3. So the height of a tree is the height of a root node. Okay. So over here, the height of a tree is 3. Okay. So let's see the depth of a tree. Depth of a tree is the maximum level of a leaf node in a tree. Okay. So over here in example, level 3 is the maximum depth of a tree. So the depth of this tree is 3. Okay. Let's see this with an example over here. Okay. So example that we here is root node, which is A, right? So A is the root node. B is the parent node of E node and F node. Okay. So E and F are children of B and B is the parent of E and F. Okay. So E and F are siblings. B, C, D are siblings because they belong to same parent. Okay. E, F, G, and D are external nodes or leaf nodes. These are the outer nodes, external nodes or leaf node. The leaf node in the sense they have no child node. Okay. Whereas A, B, and C are internal nodes. That means they have a child node. Okay. The depth of F is 2. as it is at level 0, whereas depth of E and depth of G node is also 2. The height of a tree is 2, as height of a node is 2. Over here, height of E node is 0, B node is 1, and A node is 2. So the height of tree is 2. The degree of A is 3, right? It has 3 nodes. Degree of B is 2. Degree of C is 1. So the degree of tree is 3. Okay. So this is the basic of trees that we have seen in today's lecture. Thank you.